Okay, and welcome to section 2.5, which concerns measures of the center of the data. All right, so center of a data set is also a way of describing location. So the two most often used are the mean, which we know is the average, and the median, which we know is Q2 or the 50th percentile. Okay, so remember to calculate the mean, we add the 50 weights together, divide by 50, and then to find the median of the 50 people, if we had 50 people, we would order the data first and then find the number that splits the data into two equal parts. Median is usually better measure of the center when there are outliers because it's not affected by the outliers, although the mean is the one that's most commonly used. Okay, so there are some formulas that we need to look at. And to understand the formulas, we need to know what sigma notation is. So let me show you what that is. Okay, so you might look at this and go, oh my God, what is this? It's not bad. Take a breath. It's totally fine. So what this is you have a set of numbers, and this summation, this is called summation notation or sigma notation. All it means is that you're going to take these whatever this is, whatever formula, whatever this is, and plug in the numbers for k, 1 through n, and you're going to add each of the terms, okay? And these are best understood with examples, so let's check some examples out. Okay, so for example, if you take the summation of the quantity k plus 1 squared, as k goes from 1 to n, so see, instead of k, we're going to write a 1, so 1 plus 1 squared, and then this summation tells us to add it. Then after 1 is 2. So basically you're just going countably many. You're going integers. You're increasing from 1 to m. And you keep going until you reach m. Similarly here, f sub I, where I goes from 1 to m, would be considered the same as saying f sub 1 plus f sub 2 plus f sub 3 and continuing on until you reach m, f sub m. And then here, if you have f sub I, but it's divided by some number n, then the I is the one that changes. This is called a dummy variable. It could be I, it could be k, it could be j. Really doesn't matter as long as it's, so they match. So this I matches this I. So basically that's telling you, hey, add everything here, but change the I from 1 to m every time, okay? And then add them all up together. So you have f sub 1 over n plus f sub 2 over n plus f sub 3 over n, up to f sub m over n. So let's continue. So the k, this little k, which could be k, j, I, it tells us to start with 1 usually, and it tells us to end with n or a number, a whole number. And this big sigma tells us to add, and then this is kind of like the formula or whatever it is that we're adding together. So let's look at these. Okay, so here's a couple, and at this point you can go ahead and press pause. If you kind of understand what I'm saying and you want to try these out, go ahead and do so. But if you want to work on them together, that's fine. We'll just get started right now. Okay, so let's find each sum. So here, this is my variable k. Now notice here it says, hey, change k from 1 to 5, but add them all together. So what would that look like? And if you had written 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, you were right. That is the summation as k goes from 1 to 5 of k squared, and that's equal to 55. All right. So then here, if you have the summation as j goes from 3 to 5 of 1 over j, notice that it is 1 over 3, starting with 3, plus 1 over 4 plus 1 over 5, and it ends at 5. And then that becomes 47 over 60. Now, what do you think this would look like? The summation of I as I goes from 5 to 10. So this is the starting place, 5. So if you guessed 5 plus 6 plus 7 plus 8 plus 9 plus 10, you're correct, right? Starts at 5, replaces I, goes all the way to 10, and stops there. Okay, now what if you don't have a letter, a variable to replace 1 through 6, and you just have this constant? Well, what's going to happen is you're just going to keep adding the constant by itself 6 times. So I'll show you. So the summation of a constant number with no variable is just 2 plus 2 plus 2 plus 2 plus 2. So it's 6 times going from 1 to 6, and that's 12. Okay, so why do we even care about summation notation anyway? Well, it's because, see, we use this fancy notation in our definition of the mean, okay? So this here, when it's x bar, this represents the mean of the sample. And this mu, this is pronounced mu like mu, it's a Greek letter, and it represents population mean, and population size would be n, and then sample size is n, little n. So all this means is the sum of all the data points of x, right? All your data values divided by the number of numbers. So what is this? This is just the average. We've been already doing this, and we have already been doing this as well. Okay? So here's a super fun example. So let's say we have this set 1, 1, 1, 2, 2, 3, 4, 4, 4, 4, right? We know that to take the mean of the sample, we just have to add all these up and divide by the number of numbers, okay? So it would look like we have 1 plus 1 plus 2 plus 2 plus 3 plus 4, blah, 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 and divide by 11. There are 11 numbers, which is equal to 2.7. However, consider this. There has 1 has a frequency of 3, 2 has a frequency of 2, right? 3 has a frequency of 1, and 4 has a frequency of 5. If I was to create a chart like this one, where you have the data values and their respective frequencies, meaning how many times this one occurs, you can kind of alter your formula for the mean using frequency, where you take the product of these two, because that's literally what multiplication is. Multiplication is repeated addition, is it not? So this would be 3 times 1, this would be 2 times 2, this would be 3 times 1 because it only occurs once, and this would be 4 times 5, right? So basically, if you take the product of these and add that together, that would represent the top part, and then you would divide by the number of frequencies. If you add all this up together, now remember, the sum of all the frequencies is the same as the sample size, and that's what these little symbols mean. It's just saying, this is a fancy way of saying, hey, if I add all these numbers up, I get the same as the total number of numbers. Okay, so basically, yeah, so see how there's 3 1s, there's 2 2s, there's 1 3, there's 5 4s, right? And you divide that by 11, and it's the same answer. Okay, now remember from before, this is review. We find the location of the median by plugging this into, remember you know that the median is the 50th percentile, so it's 50 over 100, which is the same as 1/2. So you could have also done, Q2, 2 over 4, which is 1/2, times the quantity n plus 1, so it would be n plus 1 over 2, okay? So let's see here. Let's suppose we have all this data, and we want to calculate the mean and the median, okay? So you have here smallest to largest. To find the mean, we know what we need to do. We need to add all these up and divide by the number of numbers, okay? And then to find the median, we need to take the number of numbers, add 1, and then divide that by 2. So here, let's go ahead. All right, so the calculation for the mean is just here. In this case, we can multiply by each one's frequency. And then there's 40 numbers total, so you divide that by 40, and then you would get 23.6. Now to find the median, we need to use first the formula for its location. So how many numbers are there? There's n, many, which in this case is specifically 40. So 40 plus 1 divided by 2 is 20.5. So we basically know, remember, if it's a decimal, it's in between 20 and 21. So the 20th and the 21st values are these two 24s. So we take the average of these two, which is just going to be 24. Now, could we have done this in the calculator, you're asking? And yes, we could have. It's the same thing as before that we used to find, Q1, Q3, all of that. It's the same calculation, so it's not too new. So let's look at this. Here we have the following data show the number of months patients typically wait on a transplant list before getting surgery. The data are ordered from smallest to largest. Calculate the mean and the median. So you could plug all of this into L1 and then this time I'm going to show you, we're going to do this again. We're going to do the one variable statistics again, and then I'm going to show you how to use L1 and L2 so you can save a little bit of time when you're plugging in stuff. So remember, you go stat, edit, and then here, this is from our last example. We have all this stuff here. So if you want to just get rid of that, so you scroll up to L1. So you hit up and then L1. Then you just hit clear and boom, clear this, enter, and all your stuff is gone. Okay. So now let's enter from the problem. We have 3, 4, 3, 4, 5, 7, 7, 5, 10s, and 3. So this is kind of like, could this be done a little easier or a little more quickly? Yeah, it could have. So this is, let's go ahead and now that we have our L1, we hit stat, calculate, one variable statistics, done, hit enter. Okay, L1, and then frequency list we skip because we haven't created a frequency list. And then we hit calculate, enter. And then there it is. It gives you, so this is your mean. Right here, X bar is your mean. See how it's like the sum of them. This is the sum of the squares of them. Here's your, this is sample standard deviation, standard deviation. We're going to get into what all of these mean. But for today's lesson, we needed this, right? We needed the mean. So 13.9, and then the median, which is 13. Okay, so write that down somewhere. And now be prepared to be amazed because I'm going to teach you another way, a shorter way how to do this. Okay, so let's get out of here. Second quit. Okay, so we start off the same way. We second, stat, edit, enter. Okay, L1, I'm going to clear this. My goodness, here we go. Clear this. Okay, enter. And then I have L2 already cleared. So what I'm going to do is I'm going to write the data value, okay, and then I'm going to write the frequency that it occurs to the left of that. So that's 3, and then 3 occurs once on my list, okay. Then I have 4. 4 happens. The frequency of 4 is also 1, okay. Then I have, what else? Well, maybe I can do this. So 5. And then 7 happens, and then 8, right? Okay, so 5, 7, 8. 5 occurs 1 time. 7 occurs 4 times. The frequency of 7 is 4. Frequency of 8 is 2. Okay, then you have 9, which occurs also twice. Okay, then 10 occurs 1, 2, 3, 4, 5 times. So 5 times. Okay. And then you have 11, which occurs once. Okay. So basically, you're putting in the values and then you're entering the frequency, the number of times that it occurs in your data set right next to it underneath L2. Okay. So 13 occurs once. And then 14 occurs twice. 15 occurs twice also. Okay, and then you have 17 occurs twice. 18 occurs once. Okay, and then we have 19 occurs how many times? 1, 2, 3 times. And then you have here 21 occurs twice. Okay, great. And then we have 22, occurs twice. And then we have 23 which occurs once. And then finally we have 24, which occurs 4 times. Okay. All right. So we have all our data values here, and then we have their frequency, the respective frequencies. Okay. So once we have that, let's go back to again. We're going to calculate the mean and the median. So let's let's quit this. Second, quit. Sorry. So stat. Okay. Now we're going to scroll over to calculate. First variable stats or one variable statistics, one variable. Okay, great. Now here's the only different thing. So you have list L1. Now when you go to frequency list, okay, that's literally the list where we put all the frequencies of the data values in L1. Okay, that's our frequency list. We created that. So you would hit second, and you can see here how L2 is in blue. So I would hit the number 2. Okay, boom, and now you calculate. See, and it's the same thing. So you still have 13 points. This time I'm going to show you, we're going to do this again. We're going to do the one variable statistics again, and then I'm going to show you how to use L1 and L2 so you can save a little bit of time when you're plugging in stuff. So remember, you go stat, edit, and then here, this is from our last example, we have all this stuff here, so if you want to just get rid of that, so you scroll up to L1, so you hit up and then L1, then you just hit clear, and boom, clear this, enter, and all your stuff is gone. Okay, so now let's enter from the problem. We have 3, 4.3, 5, 10. Okay, so this is kind of like, could this? Okay, so now let's say. Let's consider an example. Suppose you have a small town of 50 people. One person earns $5 million per year, and the other 49 earn $30,000. So let's give this a think. Which would be the better measure of the center, the mean or the median? So what do you think? What do you think? What do you think? Just take a guess. It's okay. It's okay to be wrong. Here we go. Okay. So if we took the mean, we would have 129,400. Now the median is 30,000, right? So is this value indicative of, like, does it describe everybody in the town? No, it does not, because the majority of the town earns 30,000. To say that the mean income is this, I mean, to say that this is the center of the income, it's not really correct. It's not a good measure, okay? The median is a better measure of the center than the mean because 49 of the values are 30,000, okay? So this 5 million is an outlier, okay? So the 30,000 gives us a better sense of the middle of the data. All right, so then we have here the mode. Another measure of the center is the mode. So what is a mode? That just means the value that occurs the most frequently. Okay, you can have more than one mode as long as those values have the same frequency and that frequency is the highest. If you have 2 modes, the data set is called bimodal. So here's an example. We have 20 scores for 20 students here, and you'd say which of these numbers occurs the most? So if you could kind of see right away, looks like 72 occurs the most, right? It pops right out at you. So your mode would be 72. Okay, so that's pretty much it. And then that's it. And then the only last thing I want to talk about is grouped frequency tables, meaning like, see how this let's say you have a frequency table with some grade intervals, right? Where it doesn't give you the specific grade, but it says, okay, one student earned something between 50% and 56.5%. Nobody earned within this range. 4 students earned between 62 and 68.5, 62.5 and 68.5, and so on. Okay, how do you enter this in the calculator? Well, you do the same thing with L1 and L2, except For here, for L1, you need to find the midpoint of each of these intervals, okay? And remember, the midpoint is you add the endpoints, divide by 2, or basically you find the average, and then that's your center, okay? So you plug that in, L1, L2, and then that'll give you total, the mean here, okay? That will give you the mean. All right. Yep. Okay. Let's see what else. Let's see here. All right, and that's it I have for 2.5. And the homework is 42 through 48 all. So happy studying. Good luck. Done a little easier or a little more quickly. Yeah, I could have. So this is, let's go ahead and now that we have our L1, we hit stat, calculate, one variable statistics, done, hit enter. Okay, L1, and then frequency list we skip because we haven't created a frequency list, and then we hit calculate, enter. And then there it is, it gives you, so the mean, right here, X bar is your mean. See how it's like the sum of them, this is the sum of the squares of them, here's your, this is sample standard deviation, we're gonna get into what all of these mean, but for today's lesson, we needed the mean, so 13.9, and then the median, which is 13. Okay, so write that down somewhere, and now be prepared to be amazed, because I'm gonna teach you another way how to do this, okay? So let's get out of here, second quit. Okay, so we start off the same way. We second, stat, edit, enter. Okay, L1, I'm going to clear this. Oh goodness, here we go. Clear this. Okay, enter. And I have L2 already cleared. So what I'm going to do is I'm going to write the data value, okay, and then I'm going to write the frequency that it occurs to the left of that. So that's 3, and then 3 occurs once on my list, okay? Then I have 4. 4 happens, the frequency of 4 is also 1, okay? Then I have, what else? Well, maybe I can do this, so 5. Okay, so 5, 7, 8. 5 occurs 1 time, 7 occurs 4 times, the frequency of 7 is 4. Frequency of 8 is 2. 10 occurs, guess that, right next to it, underneath L. Okay, and then you have 17 occurs twice. Occurs how many times? 1 occurs 23, which occurs once. And then finally we have 24, which occurs 4 times. Okay? Alright, so we have all our data values here, and then we have their frequency, the respective frequencies, okay? So once we have that, let's go back to, again, we're going to calculate the mean and the median. So let's quit this, second quit, sorry. So stat, okay, now we're going to scroll over to calculate. First variable stats are one variable statistics, one variable, okay, great. Now here's the only different thing. So you have list L1. Now when you go to frequency list, okay, that's literally the list where we put all the frequencies of the data values in L1, okay? That's our frequency list, we created that. So you would hit second, and you will see here how L2 is in blue. So I would hit the number 2, okay, boom, and now you calculate. See, it's the same thing. So you still have 13.9, and then your median is still 13. So it's the same, you have the same data, okay? Alrighty.